Find the point where the curves y equals x cubed minus 3x plus 4 and y equals 3 times x squared minus x are tangent to each other. That is, they have a common tangent line. Illustrate by sketching both curves and the common tangent. So I can see that in this problem I have one function and a second function. And we're trying to find the point where they have a common tangent line. Now I might have some idea of what that could be, but let's see what they say. Let's sketch out both of these curves and see what a common tangent line looks like. So we might get some ideas of how to calculate the point. So let's call our first function f of x. We'll say f of x is x cubed minus 3x plus 4. We'll call our second function g of x. So our g of x here is a quadratic. And because we see common tangent line, we might be thinking, maybe I'll have to take the derivatives of these functions eventually. And in my opinion, it's a lot easier to take a derivative when the function is in expanded form. So I have 3x squared here minus 3x. I just distributed the 3. And since we're going to draw it, it might be easier to have this function in factored form. So to put it into factored form, I can just take out 3x from each of these terms. So if I put a 3x out here, take a 3x out of this term, you just get x. Take a 3x out of here, you just get minus 1. If you multiply it back, you'll just get this expression again. So let's draw out both of these functions. So our g of x should have a root at x equals 0. That's because if we plug in x equals 0, we'll get y equals 0. If we plug in x equals 1, we'll get 1 minus 1 here, and y will also be 0. So let's say our other root's somewhere there. Let's make it a little less vertical. Okay. As for our f of x, we're not too sure what the roots are, since we haven't found a way to factor this yet. It doesn't matter too much though, because we're gonna be solving for this point algebraically, and I'll show you how. But just to see what a common tangent line looks like, let's get a rough drawing, a guess for what it might look like. So, we can't actually figure out the y-intercept. The y-intercept is when x equals 0. So if we plug in 0 here, we get 0 cubed minus 3 times 0 plus 4. So 0 minus 0 plus 4 is just 4. So our y-intercept will be around here. Let's say they have a common tangent around this region. What does that look like? Well, common tangent means that their slopes are basically the same. So let's say it looks something like that. I'm not too sure what the rest of this function looks like, but that's good enough. Now, do we notice something? We see that both of these functions touch at one point here. Now, if you get a graphing calculator out, this region will be much longer. Our drawing might not be too accurate, but it gets the idea across. It gets the idea across that if you make a tangent line to g of x at this point, you will get a tangent line that's something like this. And what I intended with this drawing is that if you make a tangent line for f of x at this exact same point, you should get the exact same slope. And that is what a common tangent line is. That is, if you take the derivative of f of x at a point and take the derivative of g of x at that exact same point, and the two tangent lines have the exact same slope, the two functions have a common tangent line. If you take the derivative of f of x at this point, you will get a tangent line like this, and take the derivative of g of x at this point, you will get the exact same line. You will get this red line. So essentially, we want to find the tangent point where this red line is made. At what point is this red line tangent to f of x and tangent to g of x? The way I drew f of x is not exactly tangent, but it's good enough. Okay, so let's write down what we know about this common tangent line. So common TL, tangent line. We know that this tangent line touches f of x and, where's my blue, g of x at the same point. So what does that mean here? We know that at this point, let's make this pink. So that means that at this point, f of x is equal to g of x, right? Because this is the same point here. If we call this point, I don't know, x equals c. If you take f prime of c, sorry, that's our next point. If we take f of c, that is equal to g of c, because it's the same point. Anyway, we'll find this. And we also know that at this point, because the tangent lines have the same slope, we know that f prime of x at this point, we know that f prime of x, which is just the slope of the tangent line to f of x, is equal to g prime of x. Right? Because that's just the slope of the tangent line to g of x. And we know that they have the same slope because it's a common tangent line. So we have our f prime of x and g prime of x here. Let's start with this second criteria. See where that takes us. So to do that, what we're going to do is we're going to take d over dx of f of x, right? Because that's just another way to write f prime of x. And that is equal to d over dx of g of x. Now all we have to do is plug in f of x and g of x. So we have d over dx of x cubed minus 3x plus 4, and that is equal to d over dx of, and we're going to take this second version here because it's an expanded form, and that'll make taking the derivative easier for us. So 3x squared minus 3x. Alright, so we just have two polynomials here. So if we remember our power rule, in case we don't remember, I'll just write it down. So d over dx of x to the n is equal to n times x to the n minus 1. So take the derivative of x cubed. You're going to put the 3 out here, decrement the exponent, and you'll get x squared. For 3x over here, if you decrement x to the 1, you'll just get x to the 0, which is 1. So you'll get negative 3. The derivative of a constant is always 0. You can also think about why that works with the power rule. And that is equal to, let's use our power rule again. Take this 2, multiply it by the 3, you get 6x because we decremented this 2. And here, just do negative 3. Alright, so now we have, now we have a quadratic. If you don't see that quadratic yet, let's move everything over to one side. So, firstly, if I add 3 to both sides, you can see that this 3, this negative 3 and positive 3, cancel out on both sides. So we get, let's switch to, I don't know, a more neutral color here. We get 3x squared is equal to equal to 6x. Move it to one side, we get 3x squared minus 6x is equal to 0. Let's factor this polynomial. So I can see that we can take a 3x out of each term. So if we take a 3x out of our first term, we just get x. Take a 3x out of here, and you just get 2. And that is equal to 0. So what does this tell us? What do we start with? We started with f prime of x is equal to g prime of x. So this tells us that at x equals 0 and x equals 2, right? Because if I plug in 2, I will indeed get a 0 on this side, and that makes this equation true. F prime of x is equal to g prime of x. So these 2 points definitely meet one criterion. I think that's the singular, yeah. One criterion. Right? So that is this criterion. But I want you to notice something. It is very possible for these 2 functions to have the same tangent at a point, but they may not have the same, they may have the same slope for their tangent line at a point, but it may not be the same line. The 2 tangents may be parallel. So for example, on our graph here, let's say x equals c at this point. If you take the derivative at this point for f of x, it'll look something like this. Take the derivative for g of x. Notice, it looks like the same slope. But are these the same line? No. And why is that? Because it doesn't touch f of x and g of x at the same point. That's why this first criterion is important. It needs to touch f of x and g of x at the same point in order for this tangent line to be common. So what do we have to check? We have to check that f of x is equal to g of x for x equals 0 and x equals 2. So we have to make sure that this tangent line not only has the same slope for f of x and g of x, but it passes through the same point. If it passes through the same point, think about it. If our line, which has the equation y equals mx plus b, if two lines have the same slope and pass through even one of the same point, all their points have to be the same. And that'll make them the same line. So I hope that makes sense. And what we're going to do now, we're going to do exactly this. We're going to check this for x equals 0. We're going to plug in x equals 0, and we're going to plug in x equals 2. So we are checking f of x is equal to g of x for these 2 points. So first let's check it for x equals 0. We're going to get f of 0 is equal to, I'll put a question mark up there, g of 0. So what's f of 0? So just a reminder, f of x is x cubed minus 3x plus 4. So if we plug in 0 for x, we're going to get 0 cubed minus 3 times 0 plus 4. We're going to get our equal sign out here with a question mark. And let's look back to what g of x is. So g of x is 3x squared minus 3x. So we've got 3 times 0 squared, because we're plugging in 0, minus 3 times 0. So 0 and 0 cancel out here, or they're just 0. So we get 4 is equal to 3 times 0 squared minus 3 times 0. Well, that's just 0. Is 4 equal to 0? No. So what does this tell us? This tells us that f of x and g of x do not have a common tangent line at x equals 0. Well, we only have 1 point left, so let's hope that works. So now we are checking x equals 2. Oh, I'll just do this in the pink so that we're staying consistent with the colors. So we're checking that f of 2 is equal to g of 2, because we already know that these two functions have the same slope at this point for the tangent line. If they pass through the functions at this point, at the same y-coordinate, essentially we were finding the y-coordinate, right, by plugging in f of 2 and g of 2. If these two functions have the same y-coordinate at this point, that means that the tangent line is common. Okay, so what is f of 2? So recall that f of x is x cubed minus 3x plus 4. So f of 2 is just 2 cubed minus 3 times 2 plus 4. And we're setting, we should probably put our question mark up here. just in case, is equal to, our g of x is 3x squared minus 3x. Yep. So 3 times 2 squared minus 3 times 2. And what do we get here? Well, 2 cubed is 8. 8 minus 6 plus 4 is equal to, this is 3 times 4, which is 12, minus 3 times 2, which is 6. And 8 minus 6 is 2. 2 plus 4 is 6. So we indeed get, 12 minus 6 is 6. We indeed get that f of 2 is equal to g of 2. So what's the conclusion of all this? So we can write our little therefore statement. Therefore, f of x and g of x have a common tangent line at the point. We know that the x-coordinate is 2. Well, what's our y-coordinate? Well, it's the same for f of x and g of x, because that was one of our criteria. And we got f of x, f of 2 is 6, and of course g of 2 is 6. So our common tangent line point is 2, 6. And if you look at our drawing here, it wasn't that off. I think my guess was kind of good there. So our common tangent point is 2, 6. It is at this point that this function and this function have a tangent with the same slope, and these two functions touch each other. All right, I hope that helped.